Hello guys, welcome back to Math Zone African Motives. We are still on our mathematics grade 8 revisions, and this is our paper 2 November exam revision that we are going to have for 2023. So we are going to consider these questions quickly. So make sure that according to the question paper that you shall be having, you are going to read the instructions which will be given and the information that is given there. So in this case, we are going to have our questions. Question number one, remember the section A part where you will be having the part of your multiple choice. So this is what you're given. Choose and circle the correct answer. All right. On 1.1, we are given which statement is true about a parallelogram. Which statement is true about a parallelogram? What is it that we do understand when we are given a parallelogram? That is what you are given in this case. All right. So we are given A, opposite sides are parallel and equal. This is what we have. Remember that a parallelogram, opposite sides, they're parallel and equal. Opposite sides, parallel and equal. All right. So this answer is correct. Let's check the second one. Opposite sides are equal, but not parallel. No, they are parallel. So this statement is wrong. All angles are equal. No, this is not a parallelogram. What we understand is that if this angle is given, it is equal to this one. Opposite angles are the ones which are equal. Opposite angles, not all. Here they are saying all. So that statement is wrong. None of the above. So it cannot be, because here this one is correct. So we cannot say this is part of our answer. So meaning to say our correct answer was going to be on A according to what you're given. So you have to choose properly in that case. On 1.2, you are given if a quadrilateral, take note, a shape that has got what? 4 sides. That is a quadrilateral. It has got 4 sides. You have angles of the following sizes. These are the angles: 53 degrees, 126 degrees, 42 degrees. What would the size of the last angle be? What are we going to have as the size of the last angle? Remember, it has got 4 sides. It also has 4 angles. And these 4 angles, provided we are dealing with what? Any quadrilateral, it adds up to 360 degrees. You are supposed to understand this. Remember, a triangle, all angles, they add up to 180 degrees. But if it is a quadrilateral, we are going to have what? 360 degrees. So how are we going to determine or have the last angle if we are given 3 angles? Remember, this is 1, 2, 3. We are given 3 angles. And remember, they are supposed to be 4. So out of 4 angles, we are given 3. So we are simply going to subtract these 3 angles from 360 degrees, because we know that these angles with the 4th one, they are supposed to give us what? 360 degrees. So we have to subtract these angles. The 53 degrees, we subtract the 126 degrees. We also subtract the 42 degrees. So you're simply going to add these together, subtract them from 360 degrees. So this is 1 mark, guys. So you can even just use your calculator without even writing this. You can just use your calculator. 360 minus, open a bracket, you add 53, you add 126, you also add 42 together like this. So that is going to give us 139 degrees. That is the last angle, the 4th angle that we have. The last angle is the 4th angle, 139. So the best answer was going to be C, where we have got 139. So this is how we are supposed to have attempted this question. If you are to figure out, or you can just try, this is, remember, this is multiple choice, guys. You know, these angles, they're supposed to add up to 360. So you can just add these angles. You take the 180, you add it to these ones, You take the 129, you add to this one until you get 360 degrees. You can also do it that way. But the proper working is the one that I've showed you there. On 1.3, the correct formula for calculating the volume of a triangular prism is what? Remember, a triangular prism, we need the base area, which is of a triangle. And what is the area of a triangle? Half base times the perpendicular. This is the base area times the height, which is the length that is taken from one side to another. So the best answer there was going to be on A for a triangular prism. You just need to know your formula. So take note there, you are dealing with the volume. All right. The theorem of Pythagoras states that. So according to the way that we are given, which one can be the best answer? Remember, if you're given a right-angled triangle, it's only that I did not talk about this, but we are going to have those classes concerning the Pythagoras theorem. If you're given two sides, which are the shorter sides, we can just call them the right sides. These two sides that we are given, let's say this is A, this is B, and this is C. The C, which is the hypotenuse, is equal to, if it is given as a C squared, its square is equal to the sum of these two shorter sides, which are the right sides. So if we want to calculate, because there we do not have hypotenuse squared, as you can see, they wrote hypotenuse, hypotenuse, hypotenuse. There is no square there. It means they removed that square. How do you remove the square from this hypotenuse? You introduce the square root like this. So it means C is equal to the square root of A squared plus B squared, where C represents what? The hypotenuse. So which is the correct answer that we have? The hypotenuse is equal to the square root of, that is the square. We must have the square root. Here we do not have the square root, which is wrong. But if they wrote it as hypotenuse squared like this, it was going to be correct. But because we do not have that squared, for us to remove this square, we must introduce the square root. So the moment the introduction of the square root is there, meaning to say this is going to be our correct answer, where the hypotenuse is equal to the square root of the right side squared, the sum, A squared plus B squared, under the square root. So that is your correct answer in that way. On 1.5, if the radius of a circle is doubled, the circumference of the circle will, considering that the radius, if you are dealing with similarity, this part of similarity, when you increase, or even the part of what can best, the similarity is the best part that we can actually describe this. If a circle is being given, it has a radius, let's say, because the radius is being doubled. So we are going to consider to say the first radius, let's say it's 1, then it is being doubled. So it means it is 2. The ratio between these two is a ratio of 1:2 between the radius. Remember that radius, the diameter, the circumference of the circle, all these, they maintain the same, the circumference of the circle. If it is centimeters, it will be just centimeters, centimeters, centimeters. So the scale factor that you are using in this case to transform this or to enlarge this into this one, which is being doubled in the ratio of 1:2, it is going to be the same. Even for what? Even for the area, I mean, even for the circumference, except for the area. But for the circumference, it is going to be the same because these ones are under the same units. If it is diameter, it was going to maintain the same ratio even for the diameter. The circumference, 1:2. But when you talk of the area, when you talk of the area factor, area, 1:2, the moment you want the area factor, you have to square that. So it will be 1:4, meaning to say in terms of the area was going to be 4 times the area if it was area. But for the circumference, it is going to maintain, that is the part of our similarity there, the same area that we have. Same ratio that we have is the same ratio for the diameter, same ratio for the circle, as long the units are the same. Remember, area is measured in square units, square centimeters, square meters. These are square units. That's why you have to square the ratio that you are given. But the circumference, the units are just centimeters or just units. So you use the ratio that is there as it is. It is not going to change. So meaning to say 1:2 means what? A double. So if you double the radius, it means the circumference will also double. But if it is the area is going to be 4 times. The area is going to be what? 4 times. The area is not going to be to double. It is going to be 4 times of what we had. All right. 1.6. What would the area of a triangle with a base of 8 and a perpendicular height of 5 be? What is the area if you are given area of a triangle, base and perpendicular? It's half of the base times what? The perpendicular height. We are given the base in this case. What is the base? The base of what? Of 8. The perpendicular height, which is what? Which is 5. So that is going to give us the area. Half of 8, which is 4. 4 times 5, which is 20. Remember, this is area, which is measured in what? Square units. Square centimeters, square meters. These are square units. Units squared. So the correct answer was going to be A, 20 square units. So take note, be very careful. D is not the correct answer. This is 20 units. 20 units. These are units that you use if you're calculating perimeter. Perimeter is the one that takes units whenever you see this part of units. But area uses what? Square. Square units. Units squared. Add all the relevant properties of the following shape on question number 2. Which shape are we given? We are considering a kite. In this case, if you have to check, remember a kite, these two sides will be equal. These two sides will be equal. The adjacent sides are equal. And if we are to consider the diagonal, we have got a diagonal that is being joined here. If we are to have another diagonal from this point to another point at the end, if you are to obtain a diagonal there, it is going to meet this diagonal at 90 degrees. It is going to meet the diagonal at what? At 90 degrees. And we do understand that one pair of these opposite angles is equal. This part of these opposite angles, this part is what? Is equal. Then this remaining part is just different. It's just a normal angle that you can have. This one is just a normal angle. You can just write this one and just put a 2 like that. These ones are not equal, but these two will be equal. This will be at 90 degrees, 90 degrees, 90 degrees. These are some of the properties that you can add. So you're talking of what? Adjacent sides being what? Equal. This one pair, only one pair that you have there of opposite angles being the same, then these diagonals, they bisect. That is at what? At 90 degrees, at 90. This perpendicular, it is perpendicular to bisect this line into 2 equal parts. It has been divided into 2 equal parts. And being at what? At 90 degrees. So which makes this triangle to be congruent to this triangle and this other triangle to be congruent to this other. So there they just wanted you to indicate some of these properties. Remember your kite, guys, in your simplification. Question number 3 on 2D geometry. Name the properties, name the following shapes. Sorry. Name the following shapes. By just looking into this shape, what can you say? By just looking into the shape. This is a parallelogram, guys. You can see even the formality of our shape, where these two sides are parallel and equal. These two sides are also parallel and what? And equal. This is a parallelogram, this one. By just looking into the shape, you must tell the shape that you're given. You cannot say This is a rectangle. Remember this, a rectangle is taken at what? At 90 degrees, supposed to be straight. These sides are supposed to be straight. And this one, you can see that it is a trapezium. These two sides are parallel. Okay, we only have one pair of what? Parallel sides. That is a trapezium that we are seeing there. All right, so this one is a trapezium. Then we move on to another one. We have got a rhombus there. All the sides are the same, and the representation is best be represented as a rhombus. Then in this case, we cannot say this is a triangle. We have to count the number of sides. How many sides do we have? This is 1, 2, 3, 4, 5, 6, 7. We are talking of 7 sides. A polygon that he has got 7 sides. Which polygon that you consider with 7 sides? That is a heptagon. A heptagon. Remember, you're supposed to know your polygons. 8 sides, octagon. 9 sides, nonagon. 10 sides, decagon. You're supposed to know the properties. Calculate the missing values in the following shapes. 3.2 in a parallelogram. Look at this shape, guys. Look at this shape. And look at this shape here. So it's just a repetition. You can even see this is the same shape. And here they're even telling you that in a parallelogram A, B, C, D, which is the same shape that they were asking you what is its name here. So you see, guys, under exam condition, also use advantage of the question paper. If there can be advantage, like maybe you're stuck and you've got something like that, you can even go back and relate to that. So they're saying in this parallelogram, remember we talked of a parallelogram, guys. I said these two sides are parallel and also equal. The same thing with these two sides, they're parallel and equal. That is, they are parallel and equal. And we talked of the opposite angles being equal. The opposite angles being equal. So we can use that information to answer our questions. What is missing? The missing values, what are we given? We are given B. We do not have any A, that is just B that we are given here. So B is equal to what? B is equal to this 5,5. Remember the issue of sides. The opposite sides are what? Parallel and equal. If we are talking of a parallelogram, opposite sides are parallel and what? Equal. Opposite sides are equal. That is, they are parallel and what? Equal. So meaning to say that is 5,5. The same value that we have is the same value that you're going to have this side, 5,5 centimeters. All right. What about the angles? The angle D is simply 95. Remember what I was saying about opposite angles in a parallelogram. We do understand that opposite angles are the same. So D is equal to 95 degrees. There we are talking of what? The opposite angles. Opposite angles are what? Are equal. Opposite angles are equal in a parallelogram. So if this angle is 95 degrees, how can we find angle C? Or if this angle is 95, how can we find C? So you can find C with any way, considering that AC is parallel to BD. So angle 95 and angle C becomes what? Co-interior. Remember the issue of the co-interior angles, the one that we form a U or a C like this inside the parallel lines inside. So if you're to consider AC parallel to BD like this, it means we have to consider this part here where we have got 95 and C, co-interior. Or you can consider if these two are parallel, if AB is parallel to CD, then we still have the co-interior, the C and the 95, they are co-interior there. We are forming a C like this. So this angle, they must add up to 180 degrees. Remember, co-interior angles add up to 180 degrees. So you're going to use the co-interior angles in any case. Is it of AB being parallel to CD, or is it of AC being parallel to BD? All right, so angle C was going to simply give us 180 degrees minus 95. Remember, co-interior angles, they add up to 180. So if we are given one angle, we subtract it from what? from 180 degrees. So it was going to give us 85 degrees. So in this case, we are talking of what? The co-interior angles. Co-interior angles. So it was going to be up to you. Are you mentioning AB being parallel to CD? It can be from that way. AB being parallel to CD, or we could have worked it from what? AC parallel to BD. So it can be AC parallel to BD. Still, we are obtaining the same answer from these lines being parallel. Any part that you wanted to use, it was also still under the co-interior angle concept. So this is what we have, guys. So we've got this angle, see, 85 degrees. So we have everything that is missing on that diagram. So that is it. This is how some of our questions, how sometimes these questions are given as. On 3.3, still on determining the missing sides or the missing values. We have got a triangle that we are given, and in this case, this one's, it was supposed to be like this here to show that these two are equal. And some of this part is not clear. There it is like this. There it is like this. Sorry, it is like this. This one is the one that is indicated here. Then this is the one that is indicated here, which is our H. This is our G, and this is our Z. All right, this was 78 degrees. This is 129 degrees. All right, there we have got our K, our M. Then this is 8. This is M. All right, I don't know the 8 there. Where is it? All right, there is an 8. All right, no problem. This is N, and this is L. All right, so according to what we are given, we need to calculate or to determine these letters H, that is the H, G, and Z. All right, that is what we have there. I think this 8 here, the M was, there's nothing, the M is, there's 8 there, so there's nothing that you're calculating there because they're already given 8 there. All right, but with this indication, what is it that we are seeing of these lines, this indication? It is showing us that the line MN is equal to the line MO. These two lines are equal. So if they are equal, we're referring to triangle MON like this as an isosceles triangle where these angles are equal. Remember that angles that are opposite what? Equal sides. So it means angle G and angle H, they are simply the same. They are simply the same. Angle G and angle H is simply the same. We are simply talking of one angle that we are referring to. So how are we going to obtain this angle that we are referring to as G or H? All right. So G is equal to angle H. So from 180 degrees, we are going to subtract, remember, angles in a triangle. That's 180 degrees minus 78. Whatever that you're going to obtain must be divided by 2 because we are saying these two angles, they are what? They are equal. So if we are to subtract 180 minus 78, which is going to give us 102, the angle that we are obtaining there is supposed to be divided by 2 because these two angles, they are what? They are equal. So that is going to give us 51 degrees. So for us to say G is equal to H, we are talking of what? Angles that are opposite what? Angles opposite equal sides. So if the angles are opposite equal sides, they are also equal. Then for us to obtain this angle that we are given, we are simply talking about angles what? In a triangle. Angles in a triangle. Sum of angles in a triangle, they add up to 180. So we have to subtract that from 180 degrees. So that's it, guys. This is 51 degrees. This is also 51 degrees. So many ways that we could have used So many ways that we could have used to find this edge. To find h, we could have determined h direct because we have a straight line, angles on a straight line. So it was going to be 180 degrees minus 129 degrees, which was going to give us what? 51 degrees. Angles on a straight line. So you can find h by that. Then you know that h is equal to g from that concept of what? Opposite. I mean the angles that are opposite what? Equal sides. You know that these two are equal. So to find h, it was so many ways. We could have used this one. Angles on a straight line. The same way that you're going to use to find z, angles on a straight line. This 78 and z, they're on a straight line. So z is equal to what? So z is equal to 180 degrees minus the other angle that you're given on a straight line, which is 78 degrees. So if we are to remove 78 degrees from this, we are going to obtain what? 102 degrees. So that is, we are talking about what? Angles on a straight line. Angles on a straight line. Or we could have used this concept. Remember that if we are given a triangle, in a triangle, we could have used this condition to find the z that we are given there. This is an exterior angle, and we do understand that the exterior angle is equal to the sum of the opposite interior angles. The opposite interior, these two angles which are inside, opposite one. So this is your z. It is equal to the sum of the what? The opposite interior. This is your interior, but the opposite, the 51 and this 51, those are the ones that you're adding. So the sum of the opposite, 51 and what? 51 was going to give us z. So z is equal to 51 degrees plus 51 degrees. So still, you're going to obtain 102 degrees. Exterior angle is equal to what? Sum of what? Opposite interior. So that is another way that we could have used. As we can see, as we are to work with the geometry, there are so many reasons. As long what you are using is valid, that answer is going to be correct. Also, finding the missing angles on this triangle that we are given. There we are given, that is a 5 here. All right, there is a 5. There is also a 5. So this indication is to show us that these two sides are equal. All right, so this is what we have. This is letter S, this is T, and this is U. Inside, we've got a 76 degrees. Inside, we've got letter E, then we've got letter D. So the angles that we are supposed to calculate are the indicated one. This E, this D, and the F there, they indicated it as a circle like this. It was indicated from this. Only that this paper is not clear, but they indicated it as a circle. Then they said this is your F. As a circle like that. All right. So if you are to consider this, let's consider this part of the 5 and the 5. The two sides that we are given being equal shows us that we are working with an isosceles triangle. And like what we had previously, the angles, these two angles, which are opposite these sides, which are equal, are also equal. Angles opposite what? Equal sides. So it means D is equal to what? 76 degrees. This one is direct. D is going to be equal to 76 degrees. That is, we're talking about what? Angles opposite equal sides. Angles opposite. We talked about this before. Opposite what? Equal sides. These angles are supposed to be equal. So if this angle is 76 degrees, we can determine angle E. How can we determine angle E? Using the concept of angles in a triangle. So we simply have to subtract these two angles that we are having, 76 and 76, that are inside of the triangle. So we have to subtract these two angles from what? From 180 degrees. So that was going to give us 28 degrees. There we are talking about what? Sum of angles in a triangle. Sum of what? Sum of angles in a triangle. They're supposed to add up to 180 degrees. So you simply have to remove those two angles from 180. Then the F, from the indication, it was indicated as a complete circle. I don't know, they wanted to indicate this part, but from the indication, it was indicated as a complete circle. So if it is a complete circle, it means we are talking about what? A complete revolution, which is a rotation. A complete rotation, that is what we have. So a complete rotation is equivalent to what? To 360 degrees. That is when you consider what? A complete rotation. So this is how these questions might be given as. You just have to be careful in your simplification how the questions are. Determine with reasons if the following two shapes are congruent. If the following two shapes are congruent. So with the look of question that we have, these two shapes are not congruent. The two shapes that we have. But the congruent figures that we had that they wanted you to specify was to state the congruent figures, not to determine if the two shapes, well, these two shapes, they are not congruent. But they wanted you to specify the shapes which are congruent, the triangles which are congruent. If you have to consider this, break this one from S to Q like this with a straight line, you are going to notice that considering this triangle SRQ, this triangle SRQ, if we are to consider this triangle, this one, and also we are to consider from V to X like this VX going to U, going to this X again, where we have got the 19, the 19, the 19, the 19, and there's a certain angle that is given, which is equal. That is the part where we can talk of the congruent figures there. Not the complete shape that we have. No, because this other side is totally different. There's a 19 there, there's a 16, there's a 19 here, there's a 23. But these two triangles are the one that they wanted you to specify. So if we are to consider in triangle SRQ and triangle VUX, we are to see that the side SR, this one, and the side VU is the same. Side SR and VU is the same. SR is equal to VU. We are given that. The angle R that we have and the angle V, this indication of these two is the same, is to indicate that these two are the same. So the angle R that we have, which is angle SRQ, that whole angle that we are given there, is equal to this one, VUX. VUX, they're equal. And also this 19 and this 19, which is the last pair that we have, which is RQ, is also equivalent to this UX. Which part are we considering there? Side, angle, side from the congruence. So in terms of being congruent, it is the triangle SRQ, which is congruent to triangle VUX. Not the complete shape, but these two triangles are the ones that are congruent. Which case are we talking about? Side, angle, side. Side, angle, side. This side and this side. The angle and the angle, the side and the side. That is what we are referring to. Side, angle, side. Side, angle, side are the same. But this other figure, this other one, there's nothing there. We cannot say those two are congruent. We can see from the size, it's 19 and 16. It's 19 is 23. They are totally different in terms of the sizes. So we cannot say the complete shape as it is. No, it cannot be the complete shape. So we have to be very careful now in our simplification also. So another question that we are given is question number 4, geometry of straight lines. On 4.1, we are given, determine the values That is the value of A, B, and C. All right. So from what we are given, from this diagram, we can see an indication of parallel lines. These two, they are what? They are parallel. We are talking about this line being parallel to this line. So what is it that we can consider from the parallel lines, guys? We can consider the issue of alternate angles where we create a Z like this. These are alternate angles where we create an F like this. We talk of what? The corresponding angles. As we can see, we are having F like that. So meaning to say the angle 56 and the angle A, they are equal, corresponding angles. If these two are parallel, this angle and this angle are equal. These are corresponding angles. So meaning to say our angle A was going to be what? Our angle A was going to be 56 degrees from that indication. If we are to consider our F like that, this A and this 56, they are corresponding angles. All right. So there we talk of what? Corresponding angles. These are corresponding angles since these two are parallel. So we've got 56 degrees. Then to find the B, we can see that this is simply a straight line that we have here. This one, it's a straight line. So we understand that angles on a straight line, they add up to 180 degrees. So B was simply going to be 180 degrees minus 53 degrees, considering to say we are working with what? Angles on a straight line. That was going to give us 127 degrees. So that is what? Angles on a straight line. Angles on a straight line. This is important for you to note. So meaning to say we have got 127 degrees. All right, what about angle C? How can we determine, or how can we have angle C? If we consider properly from the straight line here that we are having, this other straight line, you will see that there's a relationship that is happening on this line, on these two lines. Remember, if two straight lines intersect, we've got what? Vertically opposite angles are formed. Vertically opposite angles which are equal. So it means the angle of 53 here is the same as the angle of 53 inside of this triangle. Vertically opposite angles. So if this angle is 53, this angle inside is going to be also 53 degrees. So to find angle C, it was going to be easier now because you have to consider angles which are inside what? Inside a triangle that they add up to 180 degrees. So C was going to be 180 degrees minus the other angles inside of the triangle, the 56 degrees and the 53 degrees, just like that. So this was going to give us our angle C, which is 71 degrees if you simplify properly. So that is how we could have calculated this one. So many ways. You could have used, okay, so this is angles in a what? In a triangle, in short. There's so many ways. We could have used also the vertically opposed angles this way. These are vertically opposed angles. So meaning to say if this angle B is 127, this one, the whole of this angle combining with A, this other angle, this one, is supposed to be 127. So to find this other part that is remaining, because out of this 127, there is a 56, which is our A, this one. So we are going to remove what? 56 from 127. We are going to remove 56 from what? 127. This was going to give us what? 71 degrees. If we subtract 127 minus what? 1 minus 56, you're going to obtain 71 degrees. Then using alternate angles, as we are creating a Z like this, we are creating a Z. So it means angle C was going to be 71. Remember, alternate angles are equal. That's another way that you could have used. You could have calculated the 71 degrees using that way. Then you consider to say they are what? They are alternate angles we are creating a Z. As long there is a geometrical reason, use that part. Use that part. As long there's a reason that you have to specify there to say this is because of this. as long you have a reason to calculate that, use that consideration. Determine the value of angle of these angles, RKU, that is from R to K to U, this angle, which is 3P, and RKJ, R to K to J, which is this angle that we're given. So there's no way that we can determine these angles with the P, because this one is written in terms of P, 3P. This one is written in terms of P, 2P minus 55. There's no way we can have this in terms of, we have to find the value of P first before we talk about these angles. So how are we going to determine the angle of P? From where? Angles on a straight line, we do understand they add up to 180 degrees. So if I'm going to add this angle of 2P minus 55 degrees, I add to the other angle, which is 3P. I add to the other angle, which is 70 degrees. I'm supposed to obtain 180 degrees, the angles on a straight line. That is the consideration there. So consider that you have got like terms there. Consider your like terms, the issue of P. We have got 3P, 2P, and 3P there. We add these. These are like terms. So 2 plus 3 was going to give us what? 5. 2 plus 3, that is 5P. Minus 55, we add a 70. That was going to give us 15 degrees, which is equal to 180 degrees. You want to find the value of P. This is now an equation where we can solve for P. Take the 15 across the equal sign, it becomes a minus there. So meaning to say 5P is equal to 165 degrees. You can divide by 5, guys, so that we have the value of P. So divide by 5, our P was going to be 33 degrees. We are referring to angles what? On a straight line. Angles on a straight line, they add up to 180 degrees. They add up to 180 degrees. So having or knowing that our P is 33 degrees, how now are we going to determine these angles that we are given now? That is the angle RKU. So angle RKU is going to be what? So this one, it is just calculating. There's no need for a statement. It was just substituting. RKU is this one, R to K to U, like this. The angle that is this one inside. That is the angle formed. An angle is formed at when two lines meet. That is where the angle is taken. Line RK and line UK, they meet here. Where they meet, there is angle 3P. So this is the one that we need. But we must have the numerical value. We must have the exact answer. We substitute P is what? 33. Remember, 3P means 3 times. So you just have to multiply 3 times 33, which was going to give us 99 degrees. So this one is just a matter of substituting. So that was 99 degrees. To find the other angle that we are given, which is RK, that is RKJ, the way the other one that we are given, the RK to J. It is given, we have it here, it is given as what? 2P minus 55. Or you can simply subtract from 180 because we now have these two angles. So RKJ, we can simply subtract angles on a straight line. 180 minus what? These two angles, because we now know this is 99 degrees. And we also know this is what? 70 degrees. Angles on a straight line. You are going to obtain 11 degrees. Or you can make a substitution because it is there, it is given on our diagram in terms of what? In terms of P. 2P minus 55 degrees. It is given as 2P minus 55 degrees. So you just have to substitute what is our P? 33 degrees minus 55 degrees. So this is what we have. This is what we have. So you can simply simplify this. 2 times 33, which is what? 66 degrees minus 55 degrees, which was going to give us 11 degrees. So as we can see, so many ways that you can determine. As long as you understand your geometry, guys, you can evaluate this in so many different ways, which is important as you are having your revisions. On question number 5, it was area perimeter of 2D shapes. All right, so calculate. So you're complete. All right, so guys, it was, I don't know, it was just something that happened on this. It was just supposed to be calculate the perimeter and the area of the following shapes. All right, of the following shapes. This is our question here. So it was just a mix-up. I don't know what happened on the typing. Calculate the perimeter and area. So from this shape, what is the perimeter? There's an indication of the sides being equal, which meaning to say you're dealing with an equilateral triangle. From this indication, they are simply saying this is 4, this is 4. All right, we just have to use that shape as it is, but all right, that cannot be a 4 here from this indication, but from that, they wanted you to have this one as a 4. So you see, these guys also, they do not give us exact questions because it affects us, but just for the matter of your calculations, this is how they wanted you to have it. So the perimeter, remember, it is what? You are simply adding the side plus side plus side, okay? Sides that are surrounding the shape that you are given, side plus side plus side. So meaning to say our perimeter was going to be 4 plus a 4 plus a 4, the sides that are surrounding 4 plus 4, that is 8, plus 4, which is 12. That is your perimeter, which is 12 units. If they are centimeters, 12 centimeters, depending with what you're given. If they are millimeters, they are millimeters, but that's just units. Then the area of a right-angled triangle being taken at perpendicular height is given as half base times the perpendicular height. So in this case, our base is what? This 4. So we're going to take 4 as the base, and the height, the perpendicular height going up, which is what? Another 4. So what are we going to have? Half of 4, which is 2, and 2 times 4, which was going to be 8. So that is 8 square units in terms of your area. So like I said, the diagram, if you go deep into it, you see that these values are not actually the ones that, but according to what they wanted you to have, this is what you're supposed to do, okay? So sometimes, guys, you're limited to what you're supposed to do under exam. Then in this case, if you are to consider this shape, they just gave us something else because let's say, because this is just a 4, this is a 5. So you can also assume this is also a 5. But this side now is going to be difficult for us to make an assumption because we are given a 6. So let's say this is a square. Let's say this is a square. It is going to be 6, 6, 6, 6 like that. All these sides are going to be having 6. Meaning to say this side is also 6. But if we say this is 5, like this is 5, 5, 5, and this is also 5, it means this cannot be 6, but this is going to be what? This is going to be 5 because we talk of what? Opposite sides. So what are we going to have? Can we say these all sides are equal? So that is, this type of a question is not fair enough in terms of an exam condition. So in this case, if we use 6, then this is going to be a 6. All right. This is 5 and this is 5. We just assume that way. But under a normal exam, I don't know what happened with the typing or the setting of the question here. It was supposed to be properly given in terms of exam, guys. This is supposed to be properly given so that the students, they know, they are supposed to know what is it that you're in. If you're indicating that the sides are equal, give this indication to show that they're equal so that no assumptions are made. When you do not make assumptions in exam, all right? So just hope that error is going to be corrected as we move on with our revisions, because this is issue of life as you are dealing with exam, guys. You are working out your best there, then you find out there's an error there. The question is, and you cannot even understand what the examiner was trying to do. It can happen. So in this case, let us just correct this figure and use it this way. All right, so for the perimeter, we're going to calculate the distance right around the shape, meaning to say we are going to simply add the sides around the shape. There's a 5. There is a 5. Okay, there's a 6 here. There is a 6 here. There is also another 6 here around the shape, not inside. it is the distance right around the shape. That is the perimeter. You add what you see around the shape. So that was going to give us 43. All right, so we've got 43 units. So you just have to add side plus side plus side plus side plus side. The sides that you're given are the ones that you are adding. Whereas for the area, we have got area of a triangle, and we are going to consider the area of the square that we have on this other part. So the area of a triangle, remember, that's half base times the perpendicular height, and the area of a square is side squared, side times side, side squared, side times side. So you're going to have half of the base of the triangle. We are going to take it as a 6 since this is a square. So you're going to take this one as a 6. This is your base. So it's half of 6 times the perpendicular height, which is our 4. So that is the area of a triangle. Then a square, the area of a square on this other part plus side squared, which is 6 squared, or 6 times 6, side times side. That is the area of what? Of a square. So this is what we have. So from the area of a triangle, half of 6, which is 3 times 4, that was going to be 12, plus 6 squared, which is 36. So if we add this, we are going to obtain 48 square units, or units squared. That is the area of the figure that you are given, the shape that we are given. On question number 6, Pythagoras, determine the missing length of the following right-angled triangle on 6.1. We are given A, and this is right angle. We're supposed to be given a right angle here to show that that's a right angle triangle. So remember your Pythagoras theorem. The hypotenuse A is the one that is facing 90 degrees. That is the hypotenuse. The hypotenuse squared is equal to the sum of these squared, the square of this shorter side, 3 squared plus 9 squared. So remember, how do you remove the square? You introduce the square root. So it will be given as A is equal to the square root of 3 squared plus 9 squared. So that is what you're going to have. So you can simply use your calculator. 3 squared, that is 9 plus 8, 9 squared, which is 81. So you're going to have the square root of 90. You can leave it like that, or you can have it the square root of 90, which is 9,49 units to 2 decimal places. You can just use your calculator. It was going to give you 9,49. So that is the missing side, that is one that you have to calculate. Same as 6.2, but this time you are given these two. This is this indication. What does it mean? This indication, it shows us that these two sides are equal. So if this is 7, it also means this one is 7. So as you can see, guys, x is our hypotenuse, just like what we had before. X will be equal to the square root of what? The shorter side, the right side squared, which is the 7 squared and the 7 squared. So that is our x. The square root of what? 7 squared, which is 49. Also 7 squared, which is 49. So you simply have 49 plus 49, which is 98. You can use your calculator to determine the square root of 98, which is 9,90 to 2 decimal places. Or you can just leave it as square root of 98. That is our x. On 6.3, they wanted you to write down the relationship of x and y. That is, we are given in this case 1, 2, and if you had to consider 1, 2, 3, 4, 5, 2, 4, 6, 8, 10, they want you to have the relationship between these two. You can use the gradient concept finding of the equation, where we can take this as points. Remember, x and y, we can take that one as a point. 1, 2. This is 2, 4. You take it also as a point like that. So these are 2 points. So this, we talked about this in paper 1. I'm just going to use another method of finding the gradient. I don't know why is this equation even in this part is here. I don't know. All right. So remember when I talked about this finding of equation, you can determine this as a gradient. The gradient where we have got our x1, y1, x2, y2. the gradient being m, remember your equation y is equal to mx plus c. So m is your gradient, which is the change in y over the change in x, y2 minus y1 over x2 minus x1. It is a value that you can determine. Y2 is 4, you substitute, minus y1, which is 2, over x2, which is 2, minus x1, which is 1. So m was going to give us a 2, which is our gradient. So that's the one that we are going to substitute here. Y is equal to 2x plus c in place of m. We substitute our gradient. So c is a value to be determined by substituting now any of these, as long you are substituting x and y. Any part that you want. So you can substitute this one. There's 1 and 2 there. So you can substitute if x is 1, y is what? Y is 2. If x is 1, y is equal to 2. If x is 1, y is a 2. In place of x, we are going to substitute a 1. So what is going to be the value of c? So that's 2 is equal to 2 times 1, which is 2 plus c. Take the 2 to the other side. That is going to be 2 minus 2. 2 minus 2, which is what? A 0. So that c is equal to 0. So that's y is equal to 2x plus c, which is a 0, guys. 2x plus 0 is what? It's just 2x. So that's our relationship. Y is equal to 2x. Just like that. Or you can use the concept of a linear pattern. Remember when you're dealing with the pattern, the linear pattern concept. Because we can see that this is a linear pattern. The difference that we are seeing in terms of the output, the y value is the same. Between 4 and 2, 4 minus 2, that's a 2. 6 minus 4, that's a 2. 8 minus 6, that's a 2. 10 minus, that's it. They have a difference, the same difference. You can use that in form of Tn. Remember, Tn is equal to what? The difference. That is 2n plus c, where we can now find the value of c. But though this is written in terms of x now, we are going to have as y is equal to 2x plus c. But it's the same formality of a linear pattern, if you understand it that way. So simplifying or determining the equation, or which is the relationship, can be determined in so many ways. You just have to work out as many questions as you can in your revision. So this is what you're going to expect. We have the topics. What is important is going through of the topics, the Pythagoras theorem, this and that. The theorem of Pythagoras, all these that you have in your paper, to go through those basics. So like I said, for some of the areas or some of the topics that we haven't done, we are going to work on that, as we can see that we had some disturbances during this course of our revision for term 4. We were supposed to have actually covered all the topics which are supposed to be part of our syllabus, but that shall be done in the remaining space of time. So let me know, guys, on the comment section, which topics, which dates are we going to have? I know the topics that you're supposed to cover, but I want to know the dates that you are writing your finals, so that I try to squeeze in the time that we are remaining with to cover up those areas or those topics that are remaining till we meet again.